All right, today we're going to be solving equations using special cases. Not using special cases, but these are a few special cases of equations that you might run across. We've already, I think, encountered a couple of them. So these won't be huge surprises. Our goal, as always, is to get the variable by itself. Our steps to solving equations with variables on both sides is the distributive property if you can. So you're going to look for parentheses on both sides. If you have parentheses, you're going to be using the distributive property. Step 2, you're going to combine like terms on both sides if you can. And you're going to get the variable terms on one side by adding or subtracting. The variable terms are the ones with the variable. And you're going to solve the two-step equation. All right, practice number 1. We have variables on both sides. We're looking for distributive property. We don't have it. We look for like terms on either side. We don't have it. So now we need to get variable terms on one side. I notice this side has a variable term, and this side has a variable term and a constant term. So because this already has a constant term, I'm going to get rid of this variable term over here by subtracting it, because 2x minus 2x gives me 0. Whatever I do to one side, I do to the other. So I'm left with negative 8 equals 3x. I'm going to divide by 3, and I notice that 3 doesn't go into negative 8 evenly. I'm going to leave this as a simplified fraction. And it is an improper fraction, and that is perfectly okay. Practice number 2 is just a two-step equation, it looks like. I don't see variables on both sides, so I'm just going to practice by adding 5. Practice that two-step equation. And I'm adding 5 because a negative 5 and a positive 5 equals 0. Gives me 40 on the right side. Divide by 10. I get x equals 4. Be sure you're showing each and every step. Notice step 1, step 2. Practice number 3. Now it gets more complicated. Here we have distributive property on the right side, so I need to distribute that negative 2. I have parentheses, so I know I have distributive property. So when I distribute, remember you're multiplying. Negative 2 times 4x gives me negative 8x. Negative 2 times negative 11 gives me positive 22. Careful of those negatives. On the left side, I don't have distributive property. I'm just going to copy it down. I notice that the left side and the right side, they don't have like terms on each side, so I can move on by getting rid of one of my variable terms. And notice that on both sides, my variable terms are alike. That's going to be really important, because that's what happens when I try to get rid of one of my variable terms. A negative 8x plus 8x gives me 0. So I'm left with negative 6. I've got to do the same thing on this side. Negative 8x plus 8x gives me 0 here also. So I'm left with 22. Now look at this. I have negative 6 equals 22. Is that true? Negative 6 will never equal 22. So this is what we call no solution. And no solution means that there is not a single number that I can substitute in this equation for x and it will work. There will be no number that works in this equation. We can say no number works in this equation. No solution is our answer, and this is what it means. All right, let's look at practice number 4. We have negative 2 times x plus 1. We have distributive property again, so I need to distribute negative 2 times x, and negative 2 times 1 gives me negative 2. On the right side, no distributive property. I'm going to just copy this down. Oh, let me start that over. Negative 2x plus 5. Again, notice my variable terms are alike. Again, very important to recognize. So I'm going to get rid of one of my variable terms, but when I do that, because they're alike, I'm going to be getting rid of both of them. So I'm left with negative 2 equals 5, which is not true. So this again is no solution. No number will work in this equation. Practice number 5. I have distributive property again, so over here I'm going to multiply 3 times x and 3 times negative 4. On the left side, no distributive property. I'm just going to copy down what I have. Notice my variable terms are alike again, so when I get rid of one of them, I actually get rid of both of them. Because 3x minus 3x is 0, 3x minus 3x is 0. So I'm left with negative 12 on the left side and negative 12 on the right side. So negative 12 does equal negative 12. This is true, which means that we're going to have infinite solutions. And this means that any real number will work for x. You choose any number and substitute it into this equation. The left side and the right side will always, always, always be equal. So we can say any number will work in this equation. So that's what the infinite solutions means. This is your answer, and this is what it means. Practice number 6. I don't see any distributive property, but I do see like terms over here. 2x plus 2x is 4x. Bring down our plus 2. The left side is 4x plus 2 as well. I could technically look at this and say, well, the left side is exactly the same as the right side. So I know that I'm going to have infinite solutions. If we go back up here to our no solutions, at this point right here, I mentioned, oh, check this out. We have like variable terms. And notice we had negative 8x minus 6 and negative 8x plus 22. And when we got rid of our variable terms, our left side was not the same as our right side. And that's how we got no solution. Same with this practice number 4 right here. Negative 2x minus 2, negative 2x plus 5. Notice the left side is not the same as the right side. Our variable terms are alike, but our constant terms are not. So it was no solution. I could continue on with this just to prove that 2 will equal 2. and that this is infinite solutions. All right, so there are three types of equation solutions. We have one solution, which is what we've been working on up until this video. One solution would give you like x equals some number. We have no solution, and no solution would be like, for example, 3 equals 5. 3 doesn't equal 5. So when you solve it and you get to this point, if the left side doesn't equal the right side, that's no solution. We also have infinite solutions. And when you solve your equation, you're going to get something that looks like 5 equals 5. This is just an example. It could be 10 equals 10, 108 equals 108. As long as the left side equals the right side, you know you have infinite solutions. So if we look at this example here, practice 7, we can look at this and just say, oh, well, our variable terms are alike, but my constant terms are not. I can say right away that this is no solution. Looking at this one, practice 8, I'm going to have to simplify a little bit just to see if the left side is the right side. So I have to do this distributive property, and I get 4x plus 8. The left side is exactly the same as the right side. Notice my variable terms are alike, and my constant terms are alike. So this is infinite solutions. Infinite solutions means that any number will work in this equation for x.